Top of the morning to everybody. Okay, I did a little experiment here. What I did was 7 different clips, same pole, tried to do the same movement. I did it on my shoulder, so it's not exactly the same. But in the first 3, I used the AVC Intra 100 megabits per second codec on the Panasonic AG-HPX370P camera. Then the second 3 clips, I did the AVC Intra 50 megabits per second codec. And then the last clip, I did DVC Pro HD 50 megabits per second codec. Also, on the first of each of the clips, I did it at 60i frames per second. And then the second and third, I did at 30 frames per second progressive and 24p or 24 progressive frames per second. DVC Pro HD 50 did not have the option to change the frames per second, so it's only one clip that way. All right, let's go ahead and watch it and see if we see any differences. Okay, the first difference that I noticed was brightness level. Between this clip, this first clip, and this second clip, let's do that again. You can see the brightness level change. Okay, I did not change the iris between these 2 clips. There was no iris changed between the 60 and the 30. And then the 24p, there was no iris change there either. And as you notice, they progressively get brighter. Look how much brighter that red is than this red, than that red. Okay. Now on this one, there was a slight iris change here. So let's compare these last parts. This one with this one. See the brightness difference? Oh, come on, quit. Go into that clip. Okay. See the brightness difference between those 2? And now let's see the brightness difference between these 2. Okay. And then DVC Pro HD, actually, I think was darker than this one. Yeah, it's a little brighter. Okay. So why the brightness difference? Well, 60i is recording 60 fields per second, not 60 frames. There's an upper field and then a lower field. It basically creates 30 frames per second, but since it's recording 60 times instead of 30 times, it's not allowing as much light to come in. So therefore, the 30 frames per second, 30 progressive, is going to be a little bit brighter. Okay? 24 obviously is a little bit more because it's not recording as fast. So it's recording 24 frames per second instead of 60. So it can allow the light to absorb just a little bit more. All right. Now the only reason this one was a little bit brighter than these ones back here was because I opened the iris just a little bit more. Okay, so that's the first thing we notice. Second thing we start to notice is with the transitions. Watch this. Or with the pull, I should say. See how smooth that pull is? Okay, now let's watch this pull. It's a little more blurry. There's not as much definition here in these trees as there is in this one. Although these trees, it looks like there's 2 of them. But when you actually see it in motion, it tends to look a little smoother. Now let's do that again. It kind of jumped. Okay. This one, there's kind of a jitter. Boom, 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 boom. And then it goes. This one should be real smooth. Now on an interlace monitor, this looks amazingly smooth. This looks not quite as smooth. It still looks good. 24p, this is the fun one. Watch what happens during the transition. Okay, I'm going to go frame by frame. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You can kind of see like some big blur sections. There's a big blur section, then it tightens up. And then a big blur section, and then it tightens up. And it kind of has a jittery feeling to it. Okay? That's expected. That's perfectly fine. Okay. The next thing I want to talk about is, yeah, when I put these in, these were all rendered, but these clips here, okay, on this clip, if I go over to my inspector and I look at it, I can see stabilization, rolling shutter, spatial conform, compositing. Let me click on this next clip, and if I look, I can see stabilization, rolling shutter, spatial conform, rate conform. That's a new one. Okay, I'm going to pick on this clip here because this will be the best example I can show of these different rate conform settings. What this does is it allows it to take a 30p or a 24p clip and throw it into a 60i timeline and make adjustments to it. Now you don't want your timing to be off. You don't want your 24p to go faster or play faster just because it's playing in on a different type of timeline. Instead, you want it to be smooth, and you want it to follow the same time code as everything else you're editing. So here we're going to change the frame rate to 60i in a certain way. Okay, the first option here is floor. Now, I don't know exactly what floor means, but I can show you what it does. As we step through it, you notice you'll see these big jumps like this, and then it'll tighten up. It'll do 2 and then tighten up for 3. 2 and then tighten up for 3. It's basically a 2, 3, 3, 2 pull down type thing. What it's doing is it's taking every frame, splitting it into fields, and then doing a little bit of a motion blur to be able to interpolate between those fields and the fields that need to be at 60i. So when we see that, we can see artifacts like this during that rate conform that you normally wouldn't see. Okay. Let's do nearest neighbor. Render this bad boy. And let's play it back. Oh, come on. Play it back nicely. You can see a little more of a bump, 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 bump kind of feel to it. So let's run through this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You can see kind of a jitter. Probably not quite as bad as floor, but you can definitely feel a kind of stuttering feeling. And you can see that kind of jittery stuff there. It's a little bit tighter than the other one. Let's play it again. Alright, let's go to frame blending. And what this is going to do is it's going to interpolate between frames and blend the two. This should come out a little smoother looking. See how it doesn't have that jittery bump, 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 stuttery feeling, I guess? Instead, it's very smooth. Now, it's smooth, but during this kind of movement, there's a definite blur. And you can see right here, there's 1, 2, 3 trees. Now, there's 2 here, but if we were to count the blurs in here, I see 1, 2, 3, 4, 5, and 6 of those 2 trees. Well, there's 3. So we'll see 9 of them. One, 2, 3, 4, 5, 6 for sure right there. But it still looks very smooth. All right, now optical flow. This is probably the most smooth of all of them. This one's very, very interesting. This will take a 24p shot and make it look like it's 60i. It's just amazing. I don't know how it does that. It has to analyze the clip, though, before it does it. But this looks just as smooth as the next one that's going to follow it, which is 60i. Although that kind of stuttered. Let's try that again. See how smooth that looks? It's just beautiful. Okay, so the question comes up, why then would you want to shoot 24p if you're broadcasting in 60i? Well, I can give you 2 reasons. One of them is, with these other 3 rate conform processes, you will get more of a cinema look with your 24p than you will with the 60i. Because look how the 60i looks. Nice and smooth, and then 24p, not so smooth. Okay, now the reason is most films are shot at 24 frames a second. And so we're used to that kind of flickery look when we see film. Also, because of the brightness, you get a lot more dynamic range with a 24p than you do with a 60i. And you can see it's really dark. There's a lot of crunch in the blacks. The light areas are definitely a lot darker. And that's on all of them. And you can see the definite difference in brightness with 24p than with 60i. Okay, and then the third reason is if you're shooting 24 frames a second as opposed to 60, you're definitely saving space. Now remember, 60i is 60 interlaced fields per second. So it's not the same as a frame. With 60i, a frame is 2 fields. Okay, so I'm going to bring up my calculator real quick. Now remember, 60i, even though it's 60 different times being shot per second, each one is going into a field, so it's not really 60 frames per second. It's still 30 frames per second, but they're interlaced frames. It's kind of hard to understand, but basically it has to do with the way the way the scan lines go. So let's say I was doing 60i, so it's 30 frames per second, and I'm going to times that by 60 seconds. I get 1,800 frames per minute. If I times that by 30 minutes, I get 54,000 frames. As opposed to 24p times 60 for 1 minute times 30 minutes, 43,000 frames. 43,200 frames. So basically, 54,000 minus 43,200 equals 10,000 frames. We're going to divide it by 24, and we get 7.5 more minutes on 24p than we would on 60i or 30p. Okay? So for every 30 minutes, I can get 7.5 more. So if I was shooting for an hour, I'd get an hour and 15 minutes on 24p, as opposed to 30p or 60i, where I would only get an hour. All right. So to save space, that's another reason. Okay, the other thing I wanted to point out was the differences between the codecs. And I will use the 30Ps to show the differences. It's a little easier this way. Okay, I want you to take a look at this. And then I'm going to come over here. Now look at the difference between this at 100 megabits per second and this at 50 megabits per second. They're the same frame rate, different codecs. You can see a little bit more outline on the 100 megabits per second around the top of the T, right here, and along the bottom, and around here, than you can here. Oh, sorry, that's 24p right here. It's a little more blurry. Okay, now let's compare that to DVC Pro 50. There's basically no outline here at all. See how much blurry that is? Much more blurry that is? What happens is, as your bit rate drops and as your codec gets a little inferior compared to the other ones, the colors start to bleed. And red and sometimes blue are the first colors to bleed. As they bleed, you'll get stair-steppies and things like that. Here you don't see it too much. It's actually real clean right here. But you can see a little bit here. Let's go ahead and go down to here, where it's not so defined and there's not as much of a line. You can see how blurry it is right through these parts. Whereas if I bring it up here, this is DVC Pro HD, and this is the Intra 50. You can pretty much see it's a little easier to read on the AVC Intra 50. Still, comparatively speaking, the DVC Pro HD is holding up its own right there. Now let's go into the AVC Intra 100. See how much more defined the word Toyota is as opposed to DVC Pro 50? Let's compare AVC 100 to AVC 50. You can still see how much more defined Toyota is on AVC 100 than AVC 50. How clean and clear everything is. It doesn't look blurry. Look how blurry the trees look in AVC 50. Same frame rate, just different codec, that's all. And here with the DVC Pro 50, look how blurry that is. Okay, so what is the difference? Why would someone want AVC Intra 100 over AVC Intra 50 or over DVC Pro 50? Well, there's a lot of reasons. Reason number one, well, concern number one, I should say, is AVC Intra 100 megabits per second is twice as big as AVC Intra 50 megabits per second. That's obvious. One's using half the amount of megabits that this one is using. Okay, so let's say you can shoot an hour with AVC Intra 50, with AVC Intra 100. You technically should be able to shoot close to 2 hours with AVC Intra 50. Same goes with DVC Pro 50. They're both 50 megabits per second codecs. Now, DVC Pro 50 is an older, slightly inferior codec to AVC Intra. And you can see the cleanliness in the trees here between these two clips kind of show you that DVC Pro 50 isn't quite as good as AVC Intra. But why would you want to shoot DVC Pro 50 then? Well, it is an older codec, which means it's much more supported, which means the chance of your hardware being able to handle it or your software being able to handle it is a lot higher. If you're doing it in Final Cut Pro X, obviously it'll handle all of these. But some playback units can't handle AVC Intra. Some of them need DVC Pro HD, so you can use that if you choose to. Also, I do believe DVC Pro 50 takes up a little bit less space than AVC Intra, but I'm not positive. I can't be certain on that. You may now ask, well, why would I shoot in AVC Intra at 100 megabits per second when I can shoot in the other codecs and they look just fine? There's not that much of a difference. There's a little bit of a difference, but it's pretty imperceivable. Well, what happens is a thing called generation loss. So let's say I were to take this clip and export it and take it into Motion, do some stuff to it, export that, take it into After Effects, do some more things to it, export that, take it back into Motion, do some more things to that, export that, and let's say I took it into Final Cut Pro, and then I exported it and put it onto our playback server. And then I exported it from there, or it doesn't export there. It plays out and gets further encoded in our encoders to go out on the air. And when it encodes, it gets encoded to 18 megabits per second. Well, this little thing that happens is what's called generation loss. Now, what I did was I went and I exported this clip several times, and I'd export it, bring it back in, export it, bring it back in, and I did this up to 10 times. So this is the original, and this right here that's invisible here is the exported version after 10 generations. Okay? Look how clean the original is, and look how slightly dirty the 10th generation is. Toyota is a little hard to read. Used vehicles is kind of hard to read. These trees are blurry. You see the difference? Doesn't look quite as good. Okay, so now let's go to the AVC 50. Okay, now compared to the 100, the 50 doesn't quite look as good. But now, let's show the messed up version. Okay? Between the two, the AVC Intra 100 looks a little more readable than the AVC Intra 50. But let's go to the 100 and the 50 without the generation loss. Here's the 100 with generation loss, 50 without generation loss. It's actually the 100 with the 10 generation loss is almost as readable as the 50 without the generation loss. But when you include the generation loss in there, it's pretty much gone. Okay, so now let's go to DVC Pro 8 HD 50. And look how blurry those trees have become. How unreadable the word Toyota is. How unreadable used vehicles is. The things on the backs of the cars, forget them. They are gone. Now, if we compare that with this here, the AVC Intra 100, it's so much easier to read a lot of that stuff, and the trees just look so much cleaner. The trees, after 10 generations, look cleaner than the trees on DVC Pro 8 HD 50 on the first generation. So to answer the question, why would I shoot an AVC Intra 100 megabits per second, is because the cleaner that you can start, the cleaner you'll end up. There's a thing in computer in my computer learning class back in high school. I don't even remember what it was called. It was so long ago. It was called GIGO, garbage in, garbage out. So basically, if you have the garbage coming in, you're going to get the garbage coming out. If it's clean coming in, you're going to get clean coming out. Or at least as clean as possible. All right, so that was my little experiment over the 3 different codecs on the Panasonic AG-HPX370P camera, as well as the effects of the different frame rates, the effects of the different codecs, a little explanation as to why you would want to shoot certain ways. Now, and I'll just say this, if your goal is to save space and you're not going to have very many generation losses, you're just going to basically do a straight program, and it's going to be exported once and played back, or just exported to YouTube straight out, you might as well go with the space-saving codecs, because it's really not going to be that badly damaged when it's done. 1 generation or 2 generation loss is not that big of a deal. When you get up to 10, and that's what we do in broadcast, we need to stay with those higher bit rates and those higher, more definitely defined codecs. And that's because we go through much more generation loss than somebody would if they're just shooting for YouTube. In fact, the YouTube stuff can sometimes look really, really good, even at the DVC Pro HD 50, just because they don't go through the generation loss like we do. All right? So keep that in mind. Always keep in mind, whatever you're shooting, always keep in mind your target, where it's going. And that will help you determine what codec you want to use, what frame rate you want to use. There's no reason to use a 24p in broadcast as much unless you want that film look. However, if you're shooting for YouTube, you can go for the 24p, or even DVD, you can go for that 24p, because it's not going to it's going to give you that look that you can have on a 24p DVD player. All right, so keep that target in mind. You always want to shoot for the target. You don't want to shoot just for the camera. You always want to make sure your settings are set for your target. All right? So hopefully you picked up a little something from that. And I'd like to thank you for watching. Now remember, if you do have any questions and you want to ask me some questions, go ahead and I'll do my best to answer them. You can leave me a comment in YouTube or a personal message, whatever you want to do. All right, thank you very much for watching.